Hello, hello. I have a very special case today. Today I'm working on a complete A-lister's phone, celebrity. I've never worked on somebody's phone that's been so famous, so I'm very honored that they chose me. They said they did research first, and they even said I had come recommended from a friend. So if anyone from their team is watching, I very much appreciate the opportunity, and if you ever, recommend me to anybody, that would be absolutely life-changing for me. So anyway, we can get started with this. This is an iPhone 14 Pro that I'm going to be working on. It's been water damaged. It was a cool story. They were filming some really amazing stuff, and the phone has a small crack in it. It was reported as having a crack in it, but I don't actually see one. And they took it to a local repair shop first, and that repair shop took out the battery. And I can see there's quite a lot of corrosion. It's going to be a lot of corrosion around VDD main and around a lot of other components. So this will just be a severe ocean data recovery job. I've been doing a lot of live streaming lately, but in this case, this job is extremely important, more so than normal. And I wanted to make sure not to have the added pressure of the live stream. So I decided just to go ahead and make a video instead. I am glad it's a 14 Pro, however, because I don't have any videos of that one. So I'm going to go ahead and take this motherboard out of the housing, and I'm going to get started right away. There's no point in doing any type of DC power supply testing or amperage draw testing because there's obvious shorts on the board. So I'm going to remove it, and we can start working. So first step is going to be just to give it small cleaning. I am a little bit curious what I'll see when I touch the DC power supply to the battery connector, so I'll go ahead and do that. First things first, I'll clean it up a bit. So it looked to me like this was main, and then this was going to the battery charging IC. And I think I see corrosion under this shield. I see a corroded component under this shield. I don't know what that is. That might just be a coil. That might not be corrosion. But I see corrosion in here. And these were main lines that were severely damaged. The first thing I'll do, I think, because I'd like to measure main and I can't right here, is I'm going to pull this shield because there's corrosion here anyway. And I'll take a measurement at one of the capacitors that's on VDD main there. There's just a few capacitors on both of these sides, so it should be pretty safe to pull this up. Let me see what these lines are, because if this is main right here, which they're not, these are part of the charging circuit. I'll show you. So these capacitors were damaged. It doesn't matter, never mind. Okay, so now that this is exposed, I can measure VDD main at these capacitors. And let's see if it's short. I expect there will be a short, but I don't really know for sure. Yeah, so it's fully short. These, there's some chance actually that these could be causing the short. They're not on main themselves, but they connect through main through some coils. That would be absolutely amazing if somehow those took the brunt. Oh look, there's more corrosion under there. If those took the brunt of the damage. Sometimes capacitors can act like almost like a fuse, where they're just taking all of the bad voltage and dumping it into one capacitor into ground. So I'll pull this up too, because there's something going on there. Let me check where it might be dangerous to do that. Oh, there's actually main under there. So if my main short is actually under there, there is some chance I wouldn't have to split this motherboard. And if I don't have to split this motherboard, that is going to be absolutely the best case scenario. So there's obvious corrosion. I'm sure I have a main short under there. And if it clears, I will be happy. It seems to be safe to pull it from the very top up here. There's just some capacitors. I try to avoid where there might be an IC when I do this, because you can crack them pretty easily. So first things first, these will be removed, these will be removed, but I want to remove these and make sure this doesn't do any type of clearing of my lines, which I don't think they will. In fact, I even want to measure those first just to see if they're short. Sometimes even when they're corroded, they're not. Yeah, it's not even short, but I'm not going to keep them on there anyway because they look obviously terrible. That's fine. And because it's data recovery, that's why I do this razor blade method. If it's for repair, it's probably not the best technique. So I'll make sure that main is still short. It should be. I mean, those lines weren't even short. So yeah, main's still short. So at this other spot, let's see which components are on VDD main. It looks like these are main and these are main. Let's see what these are. So these were the main right here. This is all on VDD main. I can tell that because of the pattern around the PMIC. These were the other components that were damaged. They're marked as capacitors, so they shouldn't have continuity across, and I can measure that at these ones that are undamaged, but these ones look pretty bad, these two. I don't know at all what these do. I don't know what this chip does. It's probably camera or something because of the area that it's in. Let's just try to clear these caps. Okay, so we can measure these caps down here again and see if the line is still short or if that potentially cleared it. I don't suspect I'll be this lucky to not have to split the 14 board, 14 Pro, but let's see. Of course, still short, so I didn't expect it. There's a lot of damage, so that's too much to hope for. I guess I can try these ones as well, but so best course of action is going to be to split this board. And I should check under this shield too, actually. I'm almost positive I'll have to split this board right now. Just let me see if there's main under that shield before I split it. I like to pull off the shield while the bottom is attached, just because it kind of like makes it more stable in my opinion. And yeah, there's a couple things that are potentially causing main shorts under the shield, so I'm going to pull it off as well. I'm glad I pulled it up. There's obvious damage underneath. I haven't worked on too many 14s yet, of the 14 series I should say. So I'm not quite sure how well the boards hold up to severe water damage like this. There seems to be a lot of underfill in between these, so it's sealed fairly well, it looks like. So I think the inner components are actually pretty protected. Seeing this now, I'm going to check under all of these shields first before I do any type of board splitting, because there is some chance that we'll solve the board without splitting it, solve the problem. All of these small middle ones are on main. I don't know what these three were. They weren't on main, so let me see what those are. Looks like it's a... Honestly, I'm not sure what this is. It's not important though. Maybe that... Is this a Wi-Fi line? Or maybe it's a part of my NAND line. You know what? This is my NAND line. Okay, interesting. Those were on NAND. So I'll make sure my NAND lines are clear as well. Okay, I've still not even given this board any power whatsoever. Let me see what these big capacitors go to. They go to possibly wireless charging. I'm just guessing from the shape of the chip. Obviously, we don't have net names, so I don't know exactly. But let's see if possibly main is clear now. Let's cross our fingers because we cleared some main shorts right now. Maybe those were the last ones. Nope, still short. Dang. I'd say at this point it's worth checking with my thermal cam because I might be short at one of these holes now. And these don't look great. It's just hard to tell where they're going. I think I'm going to have to remove them though. So let's just do that. I mean, I can check if they're short because if they're not short, they're not causing me a problem on main. They are short. These can still be a problem, so let's remove them. Now let me see if at least those pads cleared of what that line was on. Did this clear? So that cleared, that's good. So let's see if it cleared main. I doubt it, but we can check. Still short. It's fine. It's getting less and less likely that I won't have to split this. That I will have to split. It's more likely that I will have to split it, I should say. So I'll just go ahead and do that now, I suppose. The 14 series is there's a lot of unknowns about it. We know we need the bottom board for it to not give us a 3-minute reboot, but I don't know specifically which line that is controlling that. I'm nearly 100% positive that I have a donor board, but I just realized I need to double check that because I will need a donor bottom board. So before I split this, let me go check that. So I think the best course of action is going to be just to split this board. I did kind of just check with my thermal cam off camera, and I was able to see it looked like I was getting heat right around the other side of right here. So I expect I have a short on the other side of there. So I'm going to go ahead and split this board and see if we can find the rest of the short. It's not a full short anymore on main. It's a partial short, and it's only pulling about, I think it was like 0.2 amps, so it wasn't very much. I have a donor board here, and I know I'm going to need the bottom board, and this one's likely going to be water damaged. So I'm going to go ahead and split the donor board on my heating platform first, and then I'll split the other job second. So I'll show that. I'll probably just show that second job rather than this first one. You don't really need to see it twice. Okay, so I just went ahead and split the donor, and I'll let you take a look. It came out perfectly fine. This is the first time using this tool, so it was important that I do it on the donor first and that I know exactly how it works. And it works exactly like my other tool. I use the exact same technique, which is just wait 10 or 11 minutes for it to heat up from the bottom. Don't use any top heat. And the CPU seems safe in that case. I've already even tested that donor top board to make sure it still boots, and it fully boots up, so that's fine. So now I'll go ahead and use the data job phone board, and let's split this one. So it might be a little bit faster this time because it's still a little bit warm. And I'll just go ahead and pull this camera in, and you can, watch. So I'll just go ahead and wait for this one to heat up and split it the same way. I don't use flux or anything really. I just I wait for this to get to about 225. Seems to be a good number for this heater and for the last one that I had. But keep in mind, I never calibrated these. I just poke them while it's working, and that's where I've set my reference temperatures. So I'll do this a little bit, and it will get loose at about 225, and maybe a little bit less. And because I'm only heating from the bottom, I know there's no real chance for me to damage NAND or to damage CPU on the other side. I would damage baseband CPU first, which is on the bottom board, and then the interposers heat, and then the stuff on the top board heats. So that's why I like to heat from the bottom only. Looks like this one's actually closer to 240, so my mistake. My old heater is closer to 225. Okay, the other side lifted, so this one should be just about ready as well. I think it should be fine to use the hook tool. And there we go. Okay, board is split. And it looks great on the other side. I'm very happy to see how clean it is. This shouldn't be too hard to finish. I did see one spot of corrosion, which is right here. There may also be damage underneath this chip. Let's see. Oh, the chip actually looks okay. It might be fine. So the damage, well, let's see if it's still short first. I'm curious. It may have all been on the bottom board and it may be clear now, or that last little bit may actually be the only thing left as well. So if we measure at our point over here on VDD main, no longer short. So it was mainly on the bottom board that short. So I do still have a little bit of corrosion here, and I'm not sure what a normal main reading looks like, so I'll take a measurement on my donor board, but this is showing 0.14 in diode mode. And normally main looks more like 0.3, but it can change between models, so I don't know if that actually means anything or not. Just typically a lot of the time it's around 0.3. So I'll check on the donor to make sure. I'll give it one more measurement now that that's cleaned up as well. .14. So I'll take my donor board and let's measure that instead. Let's see where I have a point I can measure from on the inside. Looks like this is main right here. Actually, this pad right here is main. So what should this normally be? So I need to find ground. Here's some ground. 0.33. So that is more normal, what I would expect, and this is 0.14. So I'll remove these capacitors. In fact, that little tiny one there is probably bad, and it's probably, both of these are pretty bad. This is probably what's bringing me the rest of the way down. The main line has so many capacitors that popping off a few for a data recovery job makes no difference. For example, this is the main line. The capacitor I just popped off was, what did I just pop off? Was right here. Why did I pop that off? Yeah, the one I popped off was right here, which I don't actually know what this line is, and this one also looks bad. And both of these look like they go into the charging IC, and the charging IC affects main, even if it's not on the same line. So it can still be causing this lower than normal reading. So let's pop off the other cap as well. This little tiny one also looks pretty bad. Okay. So let's check our main line again. And hopefully it's more normal. It might be the same. 0.14 still. So I'm going to see what kind of amperage draw I get when I touch the when I touch some voltage to the battery connector, because I have not done that yet this entire time. And if it's a very small amperage draw, I might just accept it. .04, almost 0.05 is a bit higher than I would like. So let's see if we can find where that heat's going. I should be able to find that heat with my thermal cam. So I'll try to do that. If I inject directly into main, I should get that same voltage. So let's inject directly into main just to make sure of that. If I get more voltage, that's even better. If I get less, that might mean that something else is bringing down the line that's connected to main through some other component somehow. So I know I have main right here. If I try to inject voltage, or if I just touch my probe voltage to this line, I get that same amperage draw. So that's good. So that should show me with the thermal cam where the short is if I follow the heat. I'll try to find it myself first, and then I might come back and show you if you can see it. I'll probably just try to record it this time, and then maybe I can overlay it so you see what I see. So first thing, I'll try to zoom out and see if I can just pick up any heat signature. Let's see if I can find heat anywhere. Okay, I think it's going to be coming from this chip. Let's take a look at this area on the back side. No, still not quite seeing it. You know, I have one more shield I haven't pulled on the top, and that's where I've seen most corrosion, so why haven't I pulled this shield? That's a great question. I bet you the last little bit of problem is right here. Let's pull that off. I think in this case I'll loosen this hard underfill first. I've only been in this office for like a couple of weeks, and it has a really good air conditioner here, and the AC falls right directly on top of me. And I found that I think it's affecting um, the way my board absorbs heat even. So I'm trying to figure out if I need to bump up my temperature, maybe 5 or 10 degrees from what I'm normally used to using. Um, because I'm quite sensitive to changes. I can very easily tell when things kind of feel different, and it feels a little bit different here. It also might just be that I'm not quite used to my new environment as well. Might not be used to it. There's other weird things like I'm on the second floor here, and like my camera will shake and stuff because of that. My desk is not as sturdy. If you ever pull shields in the way that I'm pulling them, you have to make sure when there's an IC near the edge not to just pull it up, because these kind of bend like inwards while you're lifting it, and you can break the chip if you're not careful. You see how when I pull it, it kind of bends inwards? So I'm trying to try to prevent that with the razor blade. And yeah, that was a good idea because it may have grabbed the edge of that chip. And on the 14, I just have no idea what that chip does. I might be able to figure it out, but I don't know yet. It looks like there may be one more over here as well, so I need to be careful on this side as well. Looks like I have some room on the corner of this one. Should be safe. I don't think there's anything else I really need to watch out for. So I'm not gonna lie, that was insanely dangerous. I didn't pay attention to what chip this was. Most chips are replaceable. This is one of 3 that is not replaceable. If you pull this shield, if you don't have to pull this shield, don't ever pull this shield, because this chip right here could be damaged and then your data is gone. And this is very close to the edge, and it will want to kind of snag that if you're not like very careful when you pull that shield. This shield didn't need to be pulled. There's no water damage in here. This is even after having gone in the ocean. There's no water in here. So typically I doubt there will be much water in here ever. In this one, I need a full backup. It's not really going to work for me to just pull the most important thing, because the most important thing is going to be included in the backup. And that's really the best and only way to transfer this data. So it's going to be safest for me to really figure out where that last short is, because if I don't figure that out, the phone may die like within the middle of the backup. And then maybe the damage would be worse afterwards or something like that. So it's just, if it's possible, I would like to figure out the last remaining pool of amperage that's not supposed to be there. But if I can't figure it out, or if it's within the board and I can't safely dig it out, I'll have to just try to power through the short, which is also probably possible, because this isn't a very bad amperage draw. It's just a small leak that would drain the battery kind of fast. Holy shit. So I want to check if it's this particularly charred spot on the actual board. So right there, it looks pretty bad. I want to see if possibly the board's shorted. It doesn't appear to be any heat in this area. Okay, that took a while, but I found it. Seems to be right here at the very edge of the board. So if I inject into main right here, you can... I was looking in the very charred area first, but it's not there. It is like right here. I was looking. I'm not seeing no heat. I'm not seeing any heat. No, I don't see it quite yet. Where is this thing? I think I found it. Sheesh. So it's quite hard to see. But let's see. Tap, untap. Tap, untap. Tap, untap. It looks to me like it's in the battery connector. There is a bit of corrosion here. It's annoying. No, that can't be it. It's probably just up here. Okay, there it is. Easy, finally. Okay, so we can clearly see where the last short is. I'll try to get it in view of you. And I'll overlay this as well. But when I inject into main, right here. Some black cables in the way, of course. There it is. When I inject into main, we see a huge spike of heat right there. So that's my last 0.4 amperage draw drain on VDD main. So once I pull that, it should be good to go. And you know what? It does appear I probably didn't have to pull this, split this board at all. I think I could have worked on the top board only, and I probably would have been fine. I don't know if these components down here would have brought anything down, but I kind of doubt it. So up here, let's verify with the freeze spray where the actual short is, just to make it very clear. So I should be able to inject right here. We should see heat somewhere over here. In this case, it seems a lot easier to see in thermal than it does with freeze spray, because nothing's heating up right away. Yeah, it's just that spot in the board. So just right here. If I took off my Barlow lens, we can really, really zoom in and see. In fact, I'll do that. There we go. This gives me some nice clarity. So this was the first spot because it looks pretty bad that I had suspected, but it seems to be okay. This over here is the spot that seems to be bad. So there's like a big divot in that pad that's probably connecting to ground. So yes, even the board itself can become short, and that sometimes becomes quite a problem, but in this case it seems like it will most likely be easy enough to clear. So I really don't want to dig too deep. Let's see if the short's any different now. Perfect. No more amperage draw. So I've cleared the short. No need to go any deeper than I've gone. So now this phone should boot, and I do wish I didn't split it because I'll have to use a jig to connect it now, which really isn't too big of a deal, but it would have been better to have avoided that. I can make sure it's actually booting with good parts first. I'm also just going to go ahead and use the original bottom board because I don't think it's damaged whatsoever. So it does look like the bottom board's good enough to use after all. It just needed a little bit of cleanup. There is some small bits of corrosion, but I don't think it's enough that will affect anything after they've been cleaned. And I don't want to worry about NFC data, so I'm just going to try to use this bottom board. Once I have it in the jig, I'll test main again to make sure there's no leaks. And as long as there isn't, then I'm not going to use the donor board after all. Before I put it in the jig, I'll just go ahead and make sure that it boots top board only because it should. Should turn on top board only with everything there, and it'll just it won't stay on longer than 3 minutes, so it's not that good by itself, but it's good enough to test that the top board is working properly. And then once I see that, I'll go ahead and put inside the jig and pull data directly. I haven't had to use an iPhone 14 jig yet, so hopefully mine works well. Even in this case, I don't think it was fully necessary to split this board. But I didn't know that at the time. Great, we got a Apple logo. Okay, so it booted. I don't know if it's going to take the password because I booted to the swipe up to recovery screen once I attempted it because it doesn't have access to the NFC data. So I will go ahead and grab my jig and let's just see if we can grab data. I think it's going to work. Okay, so I have my 14 jig here. It's the iSocket. There have been some people saying this isn't the best for baseband testing. Other people have said it's okay. Either way, I just need it for power and I prevent the 3-minute reboot. So as long as it does that, that's all I'm after. I like the way it clicked together. Last thing I need to do is check to make sure there's no current draw now that I have it connected to the bottom board again, because now I have access to all of the lines that are on that bottom board, when before I did not. And we do appear to have a small leak. But I think in this case, it's going to be best to just try to power through it. I can see real quick if maybe it showed up in the same spot we were at before. Maybe I'll just cut that part out and assume it's going to work. Okay, we're connected. So, will we connect to PC? Before I connect to PC, Will I take normal amperage through the charge port, which I might not. There was damage to the charging IC, it looked like. But I should still be booting at the very least. Okay, we are booting. And I am getting amperage through the charge port, so that's great. I think this should be fine. In this case, I can't let you see anything, not even the screensaver. I'm in, but I don't know if I'm reading battery data. There's a good chance I'm not. So let's connect this to PC, because I might not be done. I may have to fix the charging circuit still. Yeah, it's not charging, it's not reading battery data. Okay. Take a picture because this is still a good spot to be. I would like to send them an update. So it is getting late for me, so I'll have to end it here. I'll be back to finish this tomorrow. I don't want to rush myself. This, is important, of course. So I'm glad I've gotten to where I'm at. I'm glad I'm at where I'm at, I should say. And now I just need to figure out why it's not charging normally. And first thing I should do, I guess I'll check this real quick. That's why it's not charging normally. Okay, so all I need to do is fix that pin and it's going to be charging normally. Okay, I'm back today. Time to finish this job. I'm pretty sure it's going to be the pin on the battery FPC. And I have a lot of work to do today, so I'm going to try to do this as quickly as possible and just move on. So it looks like this pin is disconnected. I'll try to see if I can just get it connected first. I'd rather not replace this connector. It looks pretty good. And I only have one donor board I can pull from. So if it's possible to save any parts, I'm going to try to for this board. Okay, first things first, I'll clean it up a little bit, and then I'll probably scrape that underfill to see how much room I have to work with. That's on these components next to it. And honestly, this is probably going to be okay to just add a solder blob somewhere and get this to connect. All of these are loose too, it seems. Or maybe not. I thought they were. Okay, so I actually thought I was done with this job already, but I'm still having problems. One I found was that I need the power button flex, which is a little bit of a hassle because the wireless coil is also attached to that, so it's hard to connect. Yeah, so even after I plugged in the power button flex, I was still getting a 3-minute reboot. And I checked the panic logs, and it looks like I'm getting a proximity flex error, kind of. Um, this is where my prox flex plugs into. So I think the very first thing I should do is check diode mode on this connector because there is some corrosion here. Also, I did notice that this goes to this audio chip over here, and I had a lot of corrosion around this audio chip, so there's a chance that this is bad underneath. And historically, audio chips have caused, some audio chips have caused 3-minute reboots. I don't actually know that this is audio, but it looks like one to me. So I have the diode mode values pulled up on ZXW on my computer screen, and I'm going to check the values on my connector and see if we have anything wrong. So 623. I'm sorry, 333. So ground. 3, 3, 3. Good. 3 ground, 337. 3 ground, 3, 3, 7. 6233. 6, 2, 3. So I'm supposed to have 3 and I have OL here, so that's a problem possibly. 2, 3, 3, and then 3, 6, 4, 4. 3, 6, 4, 4. Okay, so the only problem I'm having is right here, so let's see if I can determine what that might be. So it was this third one right here. And where does this go? I feel like this one might be a misreading because it doesn't look like it's going anywhere. Luckily, I have a donor board I can compare this to. We can see if it's actually going anywhere. Oh, here it goes. It goes to the CPU. That's not good to see. So let's make sure on the donor board there should be a reading there. So I have a good donor board here that works, so I can measure that same pin. And let's see what it gives me. It was 1, 2, and 3. So yeah, this gives me 0.35, so that's what I should have, and I'm getting nothing, and it's going only to CPU, so that's a very scary thing to see. That's a problem. That is a big problem. Hopefully, okay, it may not be a problem if it's just the pin. If it's the pin, we're great, but if it's not the pin, that's a problem. You know what? I think it's the pin. I think we're fine. Maybe not. This is really not a good thing to see. If this is in fact going to be a CPU problem, if this line got somehow completely destroyed by the water, this will be a very bad fault to have on these types of motherboards because it's possible it's going to prevent data. I got this phone, I have this phone turning on, but it will only stay on for 3 minutes at a time, and that's not enough to pull any form of data. There's 800 gigs on this phone. Okay, I'm very, very happy to see we do get a diode mode measurement on this capacitor, so that confirms it's a pin thing and not like a CPU problem itself. That's a relief. I thought the pin looked okay, but I guess maybe it's not. Yeah, this one was a lot harder than I expected it was going to be. I half expected an easy job going into this. But if I'm being very honest, I do like to figure things out like this. It's pretty fun for me. It's just I'm so behind, so I don't have time to spend like several hours on the same device right now. A lot of customers are, I'm behind on my quoted time for them, and I really don't like to misquote my customers. I'm loving this iron. Okay, now do I have a reading? I do. Good, okay. Hopefully that was the reason for the 3-minute reboot. I have 2 other ideas of what it could be, which is really annoying because I don't know for sure yet. This chip could still be causing it. And also on my bottom board, my NFC chip, this is the donor right here, so what I'm using, my NFC chip right here is also corroded. So both of those things could potentially be causing the issue. But what I just fixed was also an issue that needed addressing, most likely. So let's see if that was it. Try to connect again. All right, finally, we have this backup going, and it's been on longer for 3 minutes. So this is finally stable. I'm finally pulling the data, and the new phones are always hard to learn. So this was, I've worked on a few 14 Pros and Pro Max, but I haven't had one that has been this damaged before. So there's just so many unknowns when you're working with the new models, and we get 4 new models every single year. So it's just constantly trying to have to learn. This went through way more curveballs than I expected. It was just another thing wrong, another thing wrong, another thing wrong. So thanks for watching. This was an iPhone 14 Pro that had been severely damaged in the ocean, and now my customer gets their data. So it's great. Bye-bye. See you next time.